Imagine standing in the middle of the Egyptian desert over 4,500 years ago. No cranes, no steel, no engines, no GPS, no modern machinery. And yet somehow, human beings built monuments so massive, so precise, and so enduring that thousands of years later, modern engineers are still studying how they did it. The Great Pyramid of Giza was the tallest structure on Earth for nearly 4,000 years. The obelisks of Egypt weighed hundreds of tons. Entire temple complexes were aligned with astronomical events to astonishing accuracy. Giant stone blocks traveled hundreds of miles across harsh terrain long before paved roads or industrial transport existed. For centuries, people looked at these achievements and assumed something impossible must have happened here. Aliens, lost civilizations, secret technologies. But the truth is far more fascinating. Ancient Egypt's greatest engineering achievement was not magic, it was organization. It was mathematics, hydraulics, astronomy, urban planning, and of course, logistics. And above all else, one of the most sophisticated labor systems the ancient world had ever seen. Tonight, we are going beyond the Great Pyramid itself to explore the invisible systems that made Egypt's wonders possible. How massive stones moved across an unforgiving landscape. How copper tools and sand shaped granite with incredible precision. How the Nile became an engineering highway. And how an entire civilization coordinated labor, food, water, transportation, and timing on a scale that still feels almost unbelievable today. Because the real wonder of Egypt is not just what they built, it is how they managed to build it at all. The Nile River was the beating heart of ancient Egypt. Without it, there is no Egypt as we know it. No large cities, no agricultural surplus, no pyramids, no giant temples. But the Nile was more than a water source. It was an ancient transportation network engineered into the rhythm of Egyptian society itself. Every year, the Nile flooded predictably between roughly June and September. These floods deposited fertile silt across the land and created natural hydraulic conditions that Egyptian engineers learned to exploit with remarkable sophistication. The timing mattered enormously. During flood season, waterways expanded, temporary canals became navigable, and heavy cargo could move much closer to construction sites than during dry months. This was not accidental opportunism, it was planned. Researchers now believe Egyptian builders synchronized major transportation efforts with the Nile's flooding cycles in order to move enormous stone blocks more efficiently. And some of those stones were truly massive. Granite used in royal burial chambers often came from Aswan in southern Egypt, more than 500 miles from Giza. Some individual blocks weighed between 50 and 80 tons. To put that into perspective, that is heavier than many modern military tanks. And yet these stones traveled hundreds of miles north, not by wheels, not by engines, but by river. Recent discoveries, including ancient papyri found at Wadi al-Jarf near the Red Sea, revealed records from an Egyptian official named Merer. His writings describe teams transporting limestone blocks along the Nile using boats and canal systems connected directly to pyramid construction zones. This is one of the oldest known logistical records in human history. The documents reveal something extraordinary. The pyramids were not chaotic mega projects fueled by brute force. They were organized supply chain operations. Crews had schedules, transport routes, distribution systems, administrative oversight. The construction of pyramids required coordination between quarry workers, sailors, engineers, laborers, scribes, food suppliers, and government officials across enormous distances. Ancient Egypt was operating one of the earliest large-scale state logistical systems on Earth, and the Nile was its central artery. Even once stones reached construction areas, the hardest part had only begun. How do you move multi-ton blocks across land without cranes or modern machinery? The answer appears to involve a combination of sledges, manpower, lubrication, terrain preparation, and astonishing coordination. Ancient Egyptian artwork depicts workers pulling massive stone statues using wooden sledges, while another worker pours liquid in front of the runners. For years, historians debated what this represented. Today, experiments strongly suggest the liquid was water. Moistening desert sand reduces friction dramatically. Too much water makes sand unstable, but the right amount creates a hardened surface that allows heavy objects to slide more efficiently. Physics experiments have shown this can reduce required pulling force significantly. In other words, the Egyptians may have discovered practical friction engineering thousands of years before formal physics existed. And then there were ramps. The exact ramp systems used at Giza remain debated today, but most archaeologists agree some combination of straight ramps, zigzagging ramps, circular ramps, or internal ramp systems likely played a role. What matters most is not which exact ramp theory proves correct. What matters is understanding the scale of planning required regardless of the design. Ramps themselves required enormous quantities of material, labor, maintenance, and engineering precision. The infrastructure used to build the pyramids may itself have rivaled major construction projects. Think about what this means. The Egyptians were not simply building monuments. They were building temporary industrial landscapes designed specifically to support monument construction. Entire support systems existed behind the scenes. Workshops, storage areas, food distribution centers, housing complexes, water management systems, medical care facilities. The ancient workers' village discovered near Giza revealed bakeries, fish processing areas, sleeping quarters, and evidence of organized labor rotations. These were not enslaved masses chained in misery, as older myths often claimed. Evidence strongly suggests many pyramid workers were paid laborers, skilled craftsmen, seasonal workers, and respected specialists supported by the state. Some workers were even buried near the pyramids themselves, an indication of status and honor. The pyramids were not built by isolated genius, they were built by systems. One of the biggest misconceptions about ancient engineering is the assumption that primitive tools automatically mean primitive results. Egypt destroys that assumption completely. The Egyptians achieved astonishing precision using deceptively simple technology. Copper tools were among their primary instruments: copper chisels, copper saws, and copper drills. But copper alone is relatively soft, especially against granite, so how did they cut some of the hardest stone on earth? The secret was not just the tool, it was the abrasive. Egyptian workers used quartz sand as a cutting material. The sand itself performed much of the grinding, while copper tools acted as carriers and pressure applicators. In effect, the Egyptians created an ancient form of industrial abrasion technology, and it worked. Some granite cuts and drill holes from ancient Egypt still astonish engineers because of their smoothness and consistency. Then there was leveling. The Great Pyramid's base is remarkably level even by modern standards. The difference in elevation across the foundation is astonishingly small considering the structure covers more than 13 acres. How did they achieve this without laser equipment? Water again appears central. One prevailing theory suggests Egyptian engineers used water-filled trenches or channels as leveling references. Since water naturally settles evenly, it can create highly accurate horizontal benchmarks. Simple principle. Extraordinary application. They also aligned structures with cardinal directions using astronomical observations. The Great Pyramid is aligned incredibly closely to true north, not magnetic north, true north. This required careful observation of stars and repeated measurements over long periods of time. The deeper researchers study Egypt, the clearer something becomes. These builders were not improvising. They were measuring constantly. If pyramids demonstrate Egypt's organizational power, obelisks demonstrate its ambition. Some obelisks weighed more than 300 tons, Single pieces of stone, no separate blocks, no modular construction, entire monuments carved from one massive section of granite. The unfinished obelisk at Aswan gives us one of the clearest windows into how this process worked. Still attached partly to bedrock, it reveals ancient quarry marks and extraction techniques frozen in time. Workers likely used pounding stones made of dolerite, a hard volcanic rock, to chip channels around the granite. This process could take months. Then came transportation. The obelisks had to be moved from quarries to river barges and then floated hundreds of miles north. Imagine the engineering stress involved. One mistake could crack the stone after months or years of labor, and after arrival came the most dangerous phase, raising the obelisk upright. Even today, moving and erecting objects of that size requires sophisticated engineering analysis. The Egyptians somehow accomplished it repeatedly. Archaeologists believe they likely used massive earthen ramps, leverage systems, ropes, counterweights, and carefully controlled lowering pits. Again, organization mattered as much as engineering. These projects required coordinated labor on enormous scales. Food for workers, medical care, material supply chains, housing, scheduling, and administration. Ancient Egypt was not just building monuments, it was building state capacity. Most people imagine Egypt's wonders isolated in desert landscapes, but ancient Egypt was deeply connected by infrastructure. Canals linked quarries to river systems, temporary harbors supported unloading operations, artificial waterways extended transportation reach. Recent archaeological discoveries near Giza even revealed evidence of a lost branch of the Nile that once flowed much closer to pyramid construction zones than today. This changes everything about how we visualize pyramid construction. The desert we see now was not necessarily the same landscape ancient engineers worked within. Waterways brought materials astonishingly close to construction areas, and Egypt's infrastructure extended beyond transportation. Large-scale state projects required food storage systems, taxation systems, labor management systems, and communication networks capable of coordinating activity across hundreds of miles. Scribes documented supplies meticulously. Grain had to feed thousands, beer had to be brewed, tools had to be repaired, stone deliveries had to stay on schedule. What we are really looking at is not merely architectural achievement. We are looking at one of the world's earliest examples of mega-project management. The real miracle of ancient Egypt was never simply the pyramids, it was the civilization capable of organizing them. The engineering marvels of Egypt were built not by fantasy technology or impossible mysteries, but by disciplined systems. Careful observation, mathematics, hydraulic understanding, administration, planning, and human cooperation on a scale the ancient world had rarely seen before. Thousands of workers, hundreds of specialists, generations of accumulated knowledge, all coordinated with astonishing precision long before modern industry existed. And perhaps that is why Egypt still captures the imagination thousands of years later. Because when we look at the pyramids, the obelisks, the temples, and the endless stone monuments rising from the desert, we are not just seeing rock. We are seeing evidence of what human beings can accomplish when knowledge, organization, and ambition come together. The stones themselves are impressive, but the systems behind them may be the greatest wonder of all. Imagine standing